Today I will introduce the seagrass in Norwest Philippines, the absence of the sea bank in the glacial region. And first, we talk about two features about glacial region. And the first one is glacial hemipterae is a dominant species. And glacial hemipterae is very common in the Southeast Asia. And because of its reproduction strategies, and it always dominates in the mixed seagrass meadows. And the second one is uncommon flower event. Because of the seagrass flowers, it's very fragile and it's not easy to visible. So we designate the seagrass flower is uncommon flower event. And dominant species, it means its population is stable because you need to have a lot of population so you can dominate the area. And the second one is the uncommon flower event. Uncommon flower event, it means it reproduces next generations without fertilization. And in summaries, we can know Thalassia hemipteris population is largely maintained by vegetative propagation. However, in these studies, we found that there is a large number of the fruits we found in the Northwest Philippines. What does it mean? It means asexual reproduction is not the only way to maintain its populations. Sexual reproduction is also the way to maintain. So we also know potential to form a sea bank because of the large number of fruit we found in the Northwest Philippines. So the definition of a sea bank means when flowering plant deposits seeds in the sediment. And what is the influence? The influence is it plays a major role in persistence of the populations. So we can know the survival of the various seed will be important factor to form a seed bank. So it might be explained why Thalassia hemipteris population is stable. So in this paper, we want to know, first one is there any potential sea bank of Thalassia hemipteri in Northwest Philippines? And the second one is barrier environment suitable for Thalassia hemipteri to form a persistent sea bank? So we designed two experiments. First one is a sea bank experiment, and it can explain any potential sea bank in the Northwest Philippines. And the second one is sea barrier experiment, and it can explain suitable is the barrier environment suitable to form a persistent sea bank. And first one is sea bank experiment, and we choose two sites. First site is Cedar Creek, and the second site is Carrot, and both sites is a well-mixed seagrass meadows. And first one, we choose 36 sediment cores, and in the 32 square meters site area, and the site environment is very clear. So, and this experiment we do 3 times. First time is in 1999 July, and second time is in 1999 November, and the third time is in 2000 January. And why we choose these 3 times? Because the first time in the July is because there is no fruit were observed, and the second time is there is a lot of fruit, and the third time is there is a lower number of fruit. So what do we do with the seagrass sediments? First, the sediment core were sieved by mesh size 1 millimeter shifting screen. And then to retrieving the Telesia hemiptery seed if it presents. And the Telesia hemiptery seed is almost bigger than 8 millimeters. So the seed will be on the shifting screens. And the seeds below to the 1 millimeters, we will use the stereoscope to check again. And second one is seed buried experiment. And first one, we use 42 PVC tube, and the diameter is 10 kilometers, and the depth is 15 centimeters. And because of this experiment is want to explain the different barrier level to influence the survival of the seed. So we design its control barrier level. It means the depth is 0 centimeters. And the second one is 5 centimeters. And third is 10 centimeters. And we bury all the seed into the PVC tube. We bury this PVC tube back to the seed lattice. It means we bury them back to the seedgrass needles. And second, we retrieve every second day for 2 weeks. So in the day 2, we retrieve 6 tubes. It means we have 2 control levels PVC tube and 2 5 centimeters level PVC tube and 10 centimeters level PVC tube, and for 7 days. And after in the laboratory, we count number of the certain dead seeds and measure the seed or seedling dimensions. And the result. And seed bank experiment result. And there's no Telesia hemiptery seed were found in the sediment core. And the second experiment, the barrier experiment. And the y-axis is the live seed, and the x-axis is the day after barrier. And we can see in the day 6, almost all the seed from 5 centimeters group and 10 centimeters group is dead. It means the barrier environment is not suitable for seed to live. And this is the total leaf length experiment. And it is same to the above figures, because in the 10 days, the 5 centimeters group and 10 centimeters group is almost dead too. So conclusion, that a persistent seed bank for Telesia hemiptery Bellino is absent. And the high mortality of the barrier seed suggests that these seeds are not well suited to form a persistent seed bank. And more. So the reason the seed bank is absent is rapid transition from non-dormant seed to seedling. Because the seed in the fruit is almost turned into a seedling. So when it released from fruit, it's the seedling type. So that we found that the seed bank in the Bellino is absent. And thanks for listening.